This is the Genius CP. It's in 6-axis. You can see the red light flashing here. The heli is plugged in. Transmitter is turned off. Now let's turn this on. And there we go. Now let's check the servos on here. There you go. Some throttle. Okay. So what we want to do now is simple. We want to prove that depending on the angle or the tilt of the receiver on the helicopter frame, we want to prove that it's going to affect the angle of the swash plate, which essentially will cause a drifting, which essentially in the opposite direction that the RX is tilted. So if the RX is tilted, the receiver is tilted left, the heli will drift right. And if it's tilted right, the heli will drift left, forward, the heli will drift backward, and so on. What I've got on this heli now is this kind of foam right here. Sanding block, very simple. Right, I've got some of that foam cut up, and that's the foam I'm using. It's about 3/8 of an inch thick. So I've got a lot of play here to move that guy around and demonstrate this to you. What I'm going to do now is simple. I'm going to fire up the throttle until I get to fast enough that there's no vibration, and then I'm going to be pushing on the receiver. And what you need to do is look at the swash plate here and see what it does. You'll see that it'll compensate and it will tilt the opposite direction. What this tells us is, without any ambiguity, that if the receiver is tilted on the frame, the swash plate will tilt in the opposite direction, and what you're going to have is a drifting heli. And while some people may say that you'd need a very severe tilt on the RX to cause a bad drift, or you would say, like they call it, hard left. It's not quite true really, because you don't need that much. You can see it moving right there. I don't even have the rotor turning, and you can already see the swash plate moving as I move the RX. But let's turn the rotor on and have a look. Here we go. Give it some throttle. Get it moving. About 30% here. Now first, let's just tilt forward on the RX. Watch the swash plate move backward. There we go. Now let's move it this way and watch the swash plate move the other way. Now let me use 2 fingers on there. Make sure I can tilt it nice and a lot. Check that out. Now you can actually see the stick right here. I'm not touching the stick, the aileron or elevator stick whatsoever. Just moving the RX, the receiver. Check out the swash plate go. So let's simulate a very mild lack of alignment or unleveled RX. Just a bit, just like that. Now watch the swash plate go. That's not a lot, but it's enough to cause a drift. Plenty. Cause a drift. So there you go, check the swash plate go as I move this. Now, excuse me, but if this is not enough to prove that the receiver placement is basically the main source of the heli drifting, when the receiver is not placed very well parallel to the frame in order to keep the swash plate level, if this is not enough to prove this, well, guess what? I really don't know what's going to prove to you guys that this is it right here. Nothing else to it. It's not a matter of vibration. It's not whatever you want to call it. It's the RX placement. That's it. Goodness. I don't know if you're able to see this. Actually, I know you can. This is undeniable. This is it. So if you want the heli and 6-axis to work well and fly stable, you got to work on that. You got to get that receiver in the right angle so that your swash plate will be level. And as we all know, when your swash plate is level, your heli will fly a heck of a lot better. If your RX is not level, then you got trouble. The swash plate is not level, and then the heli will drift whichever direction the swash is tilted in. I think this is enough for now. Actually, I think this is enough, period. There's not much else to say about this. Thank you for watching.